Well, thank you, and thank you everyone for being here with us today. I'm just gonna make the intro, and then she's gonna walk us through how JLL is actually using geospatial analytics. So I'm from CARTO, and what we do is spatial analytics. Probably if you're in this room, you're already familiar with this. But the main idea here is that we help people understand the difference between knowing where things are. If you're just trying to display points on a map, that's a very basic thing to do. But at the end of the day, there are a lot of correlations and spatial relationships that can help you understand a lot of things about your data. It's very difficult to understand that in any other way that is not using spatial analytics. So that's what we do. We help companies understand why things happen where they happen. How do we do that? Well, we do that working usually in very specific use cases for different verticals. As in this particular case, we're going to talk mostly about real estate investment and analysis, but you can imagine how telcos can be using something like this. It's very common also for retail, transportation, and logistics, many other verticals. And in this particular case, the way we work with Databricks is actually extending the capabilities of Databricks. In the session that we had this morning, Kent already announced that they are going to start providing native support for H3. And even though it is not native already, you can actually work with geospatial data on Databricks. So what we do at CARTO is actually extending those capabilities and helping you do kind of more things with your data. In this particular case, the data never leaves the lakehouse. You can have everything there. All the computation actually happens at Databricks, so you don't have to worry about scalability and having to use a different framework for something like geospatial analysis. And we help you, to create visualizations, creating maps, exploring your data, visualizing all your data. We have a set of UDFs that you can use to do, advanced spatial analytics, and we also have SDKs that will let you pretty much build applications and custom applications on top of this, so non-technical users can also take advantage of all those insights. That's pretty much what we do in a nutshell, and now I'm just going to pass it to Yanqing, so she can tell you how they do it at JLL.
Yeah. Thank you, Luis. So I'm Yanqing. I'm lead data scientist from JLL. So first of all, maybe I'm going to do a quick introduction about what we do in JLL. So JLL is an international real estate company. So we have business across 80 countries. So we have business in United States, in UK, in Europe, in Asia, worldwide. So with around 98,000 employees. So we are also in the list of Fortune 500 companies. So in JLL, our main goal is we are trying to help our clients, maybe from the investment fund, the investment bank or insurance company, or maybe some private investors, or maybe some IT companies or other companies in other industries. We help them in their real estate transactions, or we help them in some real estate consulting service, and maybe some leasing activities. So this is our main activities in JLL. So begin with the question, why geospatial analysis is so important in our data science project, and what's the difference between this approach with the traditional purely data science analysis? So let's begin with the key question. What's the challenge and opportunities in real estate domain nowadays, and what we mainly care about? So first of all, we care about how might we track the international trends because of COVID maybe, or because of geopolitics, and how we can understand this trend, this impact on our property value during our evaluation in real time. And how might we help our clients to meet their ESG goals, like if they want to build anything sustainable, friendly, environmental friendly buildings? And how might we provide our clients a full risk insight, not just about the price in the market, but take into account all these risk features? And how might we go beyond tabular data? So the answer will be very easy. We should take into account these geospatial features and geospatial approach in our data science projects. So let me begin with some more concrete, more detailed information. So On the left side, you might have some dark blue box. These are referring to what I call the traditional tabular data, the traditional features we might use in our daily life. So what I mean is maybe we have a list of assets in the portfolios. We have our current valuation details. We have our client informations. We have the cash flow details. We have the landlord or tenant informations, or maybe we have the property details itself, which I mean is something like surface, the year built, or the condition of the buildings. But besides that, it's missing an extremely important part for real estate analysis, which is some geospatial features. So to be more concrete, what I'm referring to is those red blocks, for example, about the regions, the neighborhood, what's the price trend in the market, what's the capital volume there, and what's the volatility in that market, and what's the offer, demand, are they balanced? We also care about the point of interest information, like if these properties has full accessibility to these transports, to the shops, to the restaurants, and maybe other informations like the airport, is it easily accessed to these points of interest, which could be important for different property assets. We also care about the environmental things. Well, it depends on the country. So some countries we have more concern about the fire risk, the flood risk, maybe tornado, or maybe other events. So we should take all these into account. So we might collect these informations from government census information, or maybe OpenStreetMap, or maybe other source like satellite image or raster data frame. Of course, CARTO also provides a full collection of different data sets from their data observatory surveys. They try to consolidate also a lot of features together. From the traditional data science project, we might have some modularized solution, which I mean is some traditional things like EDA to visualize these correlationship between the variables, and we do some data profiling, monitoring, and apply some traditional models like the clustering method, the regression, a variety of different models you might find in other traditional data science projects. But what we should do here is to connect all the dots together. So which means we need to bring these spatial models, these spatial features, these GIS layers, these big data geoprocessing all together into our ecosystem. And we should be able to connect all these dots together and bring them into full analysis. So here, the combination of CARTO and Databricks is quite a good match, because we have the extension from CARTO, which is natively supports some geospatial functions, and we can read directly the Lakehouse from Databricks data without moving them or copy them everywhere, and we can leverage some value from the CARTO visualization part. So we would like to connect all the dots together in our analysis. So that's our main purpose. For the traditional data science project, what we generally do is, here is some process process schema at high level. So from the left side, we might have a variety of different sources. It could be some extraction from the API. It could be some extraction from the SQL database. It could be some event from the IoT. It could be some geospatial shapefile or GeoJSON file. It could be also other images or other unstructured documents. And then we take these data sources together. We are trying to, our company, we use some components from the cloud in Microsoft Azure platform. So we are trying to use the data lake from Azure storage, and also we are applying the Delta Lake format, which is created by Databricks, because this could natively support a good feature of time traveling in case something goes wrong. And also it allows us to track all the versions of our data together with our model training, and we can switch and roll back between the data versions easily. And from Azure environment, we also use the Azure Data Factory to do the job orchestration, because there we can schedule and trigger our job in an automatic manner. From there, we can trigger a lot of different engines, or it's also possible to call the Databricks notebook from there. And then in terms of data processing parts, the ETL, the feature engineering, this part we can easily and nice to leverage the Databricks cluster power there. We can write some Spark scripts. We can use the famous visualization libraries like Seaborn or Plotly to easily understand do the first EDA and understand the correlation between the variables. And then in terms of the data training, we might use a lot of different libraries, depends on the specific use case, of course. We can apply XGBoost or deep learning using the PyTorch or TensorFlow, or some more basic regression or classification from scikit-learn, or depends on our use case, of course. And then in terms of ML ops lifecycle, we'd like to leverage the ML flow because it's extremely important to track your different version of models in order to compare them, and also track the whole a list of experiments. And we are aimed to tracking not just the hyperparameters, that's just one part, but we also want to check all the artifacts, or the plots, or the model performance, and also the dependency libraries, the logs, all these details. We want to track everything into ML flows, which will facilitate our future step to selection and comparing the models. Then we come to the data model serving part. We would like to package everything as a microservice, and we depends on the use case. We would choose to package all our models with its dependencies in the Docker image, and then we will be able to easily deploy it either to Azure Web App Service or Kubernetes, depends on our specific user case. And we would like to expose it as a microservice, so this can be easily shared across different or multiple applications. So I'd like to cite one sentence I heard from yesterday's ML Ops lifecycle session yesterday from Databricks. The interesting thing is they said, the speaker said, the data science product is not a model. It's more than that. Your data science product is actually the whole system, how you manage the ML ops, how you manage versioning your models, how you versioning your data. It's the whole system. We should take all this into account. And during this session, I'm going to present a selection of our projects. I will quickly walk through and briefly present the different use cases. So here, it's just some introduction pages and slides for an overview. So don't worry if you can't understand what every image mean, the meaning of each image, because I will present more details later. And I try to classify these use cases into 4 different parts, 4 different sections. So the first 2 sections, I'm going to present about the spatial analysis and spatial-temporal modeling. I will explain more details later, so don't worry if you don't understand the detail here. And in the third section, I will talk about location intelligence. So this is a domain about how to select the ideal location which meets the business needs and which meets the user's appetite. And in the last section, I would like to explain more details about what I mean in the previous hexagon slide, how we link all these dots together. So how we link the spatial analysis with our AI machine learning models, with AR visualization, how we link all these blocks together. So let's begin with the project details and use case. So first of all is something quite basic, which we call spatial analysis. So I will begin with a very fundamental and basic use case about GIS map layers. I think maybe some of you are quite familiar with it, but I'd like to present some context from our company, because we need to do a full analysis of property about a building, what business valuers or business consultants they usually do, and which is a pain point in their user journey will be. They need to collect all these informations related to the property. So basically, which means they need to maybe first they go to some government website. They need to type the name of the region, the name of the city, or the name of the market. They try to go to the website to collect these social demographic metrics, and then they switch to another website. Maybe it's the internal JLL site for a list of properties, or it could be some external listing platform like Zillow or other listing platform. So the pain points for them is they need to switch again and again and again and enter these address regions manually across different platforms. So our solution is to try to build everything in one place platform, and we try to build what we call is a multiple layer system. So here, these pictures are the real map from our project. So you might see some visualization of the human mobility information, which could be very important for retail analysis. The meaning is how many people might walk through that street daily. This is important analysis for retail. And then you might have some examples here about social demographic analysis. You might have some details about the market indicators, or you might have some details about the cadastre or other kind of layers. So once we bring all these layers together in one single system, technically we are using the CARTO platform, and we are trying to configure and coding something with CARTO.js or DEC-GL. DEC-GL is also another library famous for visualization. We are trying to code in this, and we let this component interact with our portfolio and properties. So which means they no longer need to switch again and again across platform, but they can get immediately access with a pin location of their properties, and they will be able to navigate through different maps by kind of this selection here, as I show in this example. They can easily switch and get all the information they need in one place. So if you are interested in processing this data, you might take a look of GeoJSON format shapefiles or GeoPanda or other kind of libraries to understand how you could join them together and process and transform them. And we are not just limited to visualize it as a map, because map is just one way of exploring the things. We are also interested in how we could further monetize these metrics that we've already processed, and how we can embed these metrics in our business report in an automatic manner. So here, this is an example. We try to consolidate the information about the infrastructure, basically means the station to the railway, the access to the airport or the bus station or metro. We consolidate also the information about market, what's the market price trend there, what's the volatility, what's the volume, what's the demand and offers, what's the occupancy maybe. We also consolidate the demographic and social economic informations. We also consolidate the point of interest that I mentioned in the very first slides. We also consolidate other environmental features and metrics that we pre-computed. We consolidate everything here And we expose some kind of microservice API, which allow us to return, given longitude and latitude as input, we can extract in real time and immediately from this API a list of all these metrics, what I mentioned in the previous slide, in an automatic way. So we just need to get a location from the properties, and then we will have the full access to all these scores related to different dimensions, related to no matter social economics, market, point of interest. We have everything extracted in an automatic way. So this is what's about spatial analysis. And then I'm going to present what I mean about spatial-temporal modeling. So here in this screenshot is a screenshot of one of our projects. What we are trying to do is we have a list of transactions. So they are geo points with different price, with different date. And then we believe, for example, the similar properties in New York, Texas, or California, or Chicago, they could have totally different property value. Even the property features, they are similar. So this is and even for the same property at the same location, this year and last year, they could have a totally different price. So that's why we are trying to apply some kind of spatial-temporal modeling here. So if you are interested in more details about these functions, I would recommend some Python geo-interpolation libraries or some time series analysis itself. Of course, the CARTO has also built some analytics toolbox, which is ready to use. And from the theory part, if you are interested, I will recommend you to read some books about geospatial temporal modeling with a pretty GIS statistics approach, but which indicates this geospatial trend and time trend, which is very important for a lot of retail or real estate analysis. So our next project is about property grouping. So in simple word, this is an entity resolution solution trying to put all the information related to the same property together. So this is a basic visualization that we built in 3D, which can try to consolidate all the offers and transactions and attach them to the same building model in order to give some kind of visualization. So what we are trying to do is we have so many sources which publish the sale transactions, or maybe lease transactions, or maybe offers, or maybe portfolio or historical valuations, or maybe tenant details. These informations, they all come from different data provider maybe, or it's come from a different system. So technically, there's no way we get an technical ID, which allow us to do a left join very easily. Of course, maybe some people might think about standardize the address and just compare the address. That could solve part of the issue, but that's not an ideal solution. The reason is we have so many cases about the properties. They indicate different floors of the same building, or in another cases, the same building, they have multiple entries. So each entry, they have totally different address. So purely based on the address, the source already have different formats. And even we are trying to standardize them, we will not get a perfect match by this naive approach. So what we are trying to do is we are trying to apply some more complex clustering methods, which allow us to take into account not just the address line, but also the geolocation itself, or maybe other features like the surface, the transaction date, or other maybe tenant informations. We combine all these features together, and we do a clustering. We can choose different method, but here we are using the dbSCAN, which is a density-based approach, and we need to select a proper threshold. We need to explore a little bit, and this approach might allow us to do a clustering across sources. So it's not just allow us to compare source A with source B with with some naive exact match based on the address line, but it allows us to clustering a multiple source, maybe 20, or together with a cluster ID directly. So this can solve and apply a better result to our analyses. And third section, I will talk about location intelligence. As I quickly explained, this is a study about we have the clients or business, they have something in the mind. They have their appetite or they have their requirements and how we can help them to select the best ideal location. So we have a project which is called Property Scorecard. From the data part, we leverage the metrics that I already explained maybe in the first section. I think, I don't know if you remember about these map layers, about this automatic reporting. We are consolidating all these sources together for different dimensions. So here, we build a kind of schema and some logic which allow business to specify, okay, what's the most important metric and what they care most for that specific line. So to easily explain with one example, for example, some investors are going to invest in some student housing maybe. So what they might care the most is about the demographic distribution. Is there a lot of young people, a lot of students there? They care about the distance to the university. They care about the access to the transport because students need some convenient location to have the full accessibility to these transport. They might also care about other point of interest features like is there a lot of restaurants, shops, and bars because that indicates the quality of life. So we have pre-computed some models, some scores for these metrics for locations, for any locations. And then we let user send a post request, specify what they care most. By applying a weight, we can adjust different weight according to their preference, what they care the most. And then we send it to our microservice, and as a result, we will return to them a list of ideal locations which meet their appetite, and we will return a list of potential candidates for properties which meet perfectly their appetites and their requirements. So, of course, I use student housing as an example, but our use case will not be limited to that. It could be senior housing, retail shops, or even for companies who want to move their location of the office. They might have some appetite, and they can specify, and we can return the best location to them in an automatic way. And we also have another project about Mappergy. This is similar as the previous one in sense of we want to find out the best location. The different part of this is here we are trying to identify the best location to install a solar panel or to install some renewable energy stations. So in terms of data processing, we will do a slightly different approach because our source data will be some raster formats instead of some traditional polygons or vector formats. So we might have some raster formats or other satellite images because basically what we are analyzing here is the solar energy, the strength of the wind in that region, and also the terrain elevation, because some shape might be very complex to install a solar panel there. So we are trying to consolidate these features together, and then we apply some similar approach, let user to specify the appetite. Maybe they want to target at a specific region, and then they they would like to have a fine filter to select the best cadastre to install the best location for the solar panel. And here is also an example of the interface we built with CARTO Builder, which allow us to quickly build some kind of map, interactive map with the histogram, with the filters, with just some drag and drops, and with this plot of distribution of the attributes. So the idea is very similar. It's for selecting the ideal location, but with a different use case and with different source formats as a raster data input. So if you are interested in explore more technically, you could read some details about the GDAL document, or maybe raster frame or raster IO. We have, or even GeoMesa. It depends on the volume of your data, but these libraries will also allow us to do some aggregation or some further analysis by raster data. And also, we have the Google and Earth Engine, which has a full collection of different raster formats data in case you are interested. And last section, I'm going to present how we connect the dots together, connect these components together. So we would link these special features with some of our machine learning models. So in JLL, we have trained a model which we called AI valuation model, which is aimed to let user input address line, input some basic features like the surface, the building conditions, and then we are aimed to give a prediction about the building's rental income and sale price in an automatic way in real time. So we might take some the tabular information that I already explained what I mean there. But furthermore, we are also trying to enrich this information with the special features. So here are a couple of examples. On the left top side, you might see boundaries. These are census statistic informations, which allow us to extract the social economics informations to enrich it. And left down side is we pre-computed with some model for a point of interest index, which allow us to evaluate if that location have a full accessibility to the shops and these services. And on the right side, we have a screenshot of market price trend index. So you can easily identify here. Obviously, Manhattan has a much higher price in general compared with the region on top of it. And we also leverage some computer vision model, trying to classify the grid of satellite image and try to label them for the land use, or trying to identify is there any evolution in that region, is there anything new built there, is there any change of land use there. And after the classification and labeling, we can transform the result as some grid or some polygon, and if we want to visualize it, we can push the results to CARTO for the further visualization. And furthermore, we have also trying to integrate some of the map analysis with our AR modules. So if you are interested in this part, you can further explore the AR kit or AR core, depends on the you are using the iOS or using the Android. And then we can combine all these modules together with some AR applications. So this allows us to visualize the results, the map, and interact with the real camera, so it can give users some immersive experience of the exploration, or it can improve our interactive way with our clients in case we need to do any presentation or any showcase. So these can be all linked together with AR or even with VR. If you are familiar with some VR engines and platform, these things can be all linked together. So that's about the brief presentation about a selection of our projects. And of course, I know in these sessions we don't cover that much the demo of the interface of CARTO itself, or we don't cover that much the how we are going, a kind of tutorial, how we going to link CARTO with Lakehouse. So for that part, if you are really interested, I will strongly suggest you to review another session from one of our colleagues from CARTO, Isabel, who has a perfect session who presents how we can link CARTO directly with Lakehouse without moving the data and copy the data. And she has also a demo and kind of tutorial in case you want to explore some more details. So thank you, and don't hesitate to connect with me, connect with Isabel or Luis in case you want to know some detail or use case about CARTO, and don't hesitate to connect with me in case you are interested in any geospatial data science project or other data science related topics. So thank you.
Thank you.